You know that we are starting a new module, that is the Science and Tech module for prelims as well as mains part. And here we are going to see in the next 10 days, what we are going to do is we try to highlight the different segments, what we have it in the, what do you call the syllabi, what you have in the mains as well as in the prelims. Okay. So it'll be mostly navigating through different types of questions of what they have asked, and accordingly we will discuss the different aspects. Okay. So when we discuss a particular topic, say for example nuclear energy kind of, so in that way what we try to do, we try to discuss the basics, and then we'll come up with uh, and then the concepts, basics, concepts, and current affairs. So this is a logic what we are going to do. And there is a topic, what you call it as day-to-day current affairs, or I mean day-to-day thing what we have. In that way, we can also concentrate on those areas in the last segment. Okay. So this possibly the basics and also what do you call concepts and the current affairs related. So we try to cover. So those who are attending this year, in case if there are, you can also use it for the current aspects. But it is general discussion. So it is not specifically for the prelims part, because all basics will be covered and all part of the concepts will be covered. It's not only specifically for prelims. So it is for prelims mains combination. So it's a combination kind of. Got it? Fine. So in that way, so we'll start gradually in this aspect. The first and foremost thing what you need to know is the basic syllabi what we need to have, or what we were given by UPSC in general. So you know that the UPSC has given a basic topics like this: science and technology, developments and their applications, effects in daily life, right? And then achievements of Indians in science and technology, indigenization and developing new technology. So both indigenization, developing of new technology, then basic awareness in IT, computers, space, defense, nuclear, robotics, nanotechnology, biotechnology, and specifically IPR. Okay. So here, when you prepare, so basically you need to give importance for the development. Development means the emerging aspect as well as their application. So predominantly what they ask, say for example, what is 3D printing? So they are asking like this, okay? And what are their application? So this is a basic question what they ask in mains, right? So you can see it's very simple. And similarly, a couple of years before, you can see ISRO's achievement. So in various aspects, when Chandrayaan was happening, so they, in general, they asked for what are the basic achievements what ISRO has done all in all these aspects. So in all these set, so they are concentrating on emerging and their application part and basic achievements what Indians have. And in case of any indigenization happens, say for example in a missile, okay, or in nuclear technology or in biotechnology, in case of you see it as indigenization, give importance to it. Okay, so when you see a word indigenization is happening, say 100% is developed by Indians, then give importance to it. Okay, and in case if it is a new technology which is coming in, say for example, way back there was a question on oil zappers. So in prelims, so first time we developed a new technology for us for tackling oil spills. Okay, so like this. So similarly, every component we have questions. So especially space, defense, nuclear, nanotech, and biotech. So these five are the basic concentration of questions, both prelims as well as mains. Right. So we'll see one by one, and we'll go on interacting with this. The basic source what you can have is your NCERT. So NCERT doesn't have specifically for, I don't recommend NCERT directly for science and tech kind of. But certain topics, say for example, biotechnology. So you have it behind biology part, geography part. So you have some biodiversity, biotechnology related areas. So selective readings from your NCERT books, what you have, different books in different subjects. So wherever you have some defense information, space information in geography, technology information from biology part. So those you can collect. That is enough from NCERT. Whereas your current updations will be from your newspapers and magazines. So from them, you can get a good insight. Okay. So for the new development for new technologies which are introduced, some insights on emerging technologies. So you can use another important thing. NISCARE has a thing called Science Reporter. Okay, Science Reporter. So there is a magazine called Science Reporter, and that particular magazine can be utilized by you, and that will be very, very helpful for you for what do you call science related, especially the upcoming news and some insights. Say, for example, when magnetic levitation is there, when a train, high-speed train is there, they will give you an entire aspect of the particular technology. So that will be very, very helpful. So you can rely upon this Science Reporter. You can even subscribe them. Physical copy also, or in I think even now soft copies are available. So this is a better source. Okay. So in case if you are a beginner, you can use these sources. Okay. Apart from that, basic information from NCERT, Science Reporter, your current affairs information is well and enough for the aspects. Got it? So any doubt up to this? So what to prepare? Clear? Okay. So now we move on to
Sir, NCERT, which standard books
and
are
that's
we
what you
supposed
don't go with the standards. So when you take geography NCERT, in the last part of geography, in the biodiversity and all, they'll discuss. There will be some information about biotechnology there. Okay. In biology NCERT, in the last chapter, you can see some information on biotechnology. Similarly, in geography, you have information about some satellite related. Okay. Geosynchronous, geostationary, satellite information will be there. So slight that selective reading is enough. Okay. So you need not read of physics, chemistry, botany, zoology, kind of. Got it?
Okay.
So that's idea. Fine.
Thank
So,
you.
okay. So these are certain basics what we need to do. And now what we try to have, so we try to go for the basic understanding of fundamentals of science with respect to people who are for targeting prelims. So there are some conceptual questions also they have asked, and these will be basics for understanding the space, nuclear, and other aspects what we are going to discuss in future. Okay, so today's class is going to be more of what you call the basics. What do you call? I mean your fundamentals of physics. Okay, in general. Okay, which will be helpful for understanding other aspects in the class to continue. Okay, so anybody who are not from science background in your graduation, that is you have discarded science by 10th standard itself. So 11th, 12th, you would have taken C group or any other, and then you would have continued with graduation also without science. Anybody there?
Yes, sir.
So you one is there. Okay. Done. Apart from that, okay.
Yes,
so,
sir.
Couple of them are okay. So one or two are there. Okay, fine. So accordingly, I will match it out. Fine. See, generally, when you have questions in based on science and technology, UPSC is very clear that they are not going to test your science knowledge. Okay, they are going to test your scientific approach or a basic scientific concepts which you have at least by 10th standard you would have read, right? So when they are testing concept, they will stop there. But when they are asking certain things which is in current affairs, they will be directly asking that particular technology, and that too, what is what. So you could have seen that many times there were questions which are there, which were happening in this particular aspect, where the questions will be more what is what type rather than explanation type. Okay. So even if they are going in detail, it will be mostly from the current issues, and rather there won't, it will appear only on that particular year and it will not be carried forward. Okay. So this is a basic justice what they actually do. Okay. So we will have just an understanding. I'll ask some questions. You will slowly start to answer it. Okay. So in general understanding of science, so when you begin science in schooling, the first part what you would have been started was with the concept of matter, right? So this is the first chapter in physics, in a basic science, what you would have gone with. Okay. So can anybody define what matter is?
It is something that has a mass
Something which has mass.
occupies
That
space,
is,
that
mass
occupies-
means, mass is a concept, right? But I don't know what mass means, but how you put it in a simpler form, even simpler.
which occupies some space.
Occupies some space. Okay, so that's a simpler thing. Matter means something which occupies a space. So you place something and it is going to occupy some space, that we call it as matter, right? And this particular space which is occupied is classified into three, and that traditionally, okay, traditionally three states of matter. We call it as states of matter. What is states of matter? In what uh, what do you call it?
In what form it
Form, yeah, in what form it is going to be, okay, that we call it as states of matter. Okay, so we have
Solid, liquid,
solids,
gas.
Liquids and
liquids and gases. So this is traditional. So modern times we have plasma. Okay, so other forms are there, but we generally confine with this solids, liquids, and gases. Okay. So this particular matter which occupies some space can be of different shapes, different sizes, different characters, right? So this particular matter, which can be solid or liquid or gases, in general, we classify them into two. One is particle. The other one we call it a substance. Okay. Both occupy some space. So particle means, it is the smallest one. So it is the smallest unit of a matter. We call it as particle. Yeah. Whereas substance, what is substance in general? When you use the word substance to define a matter.
Group of particles.
Okay, group of particles, fine then. How that particular group of particles will be?
Maybe mixed or
Okay.
even are the same group of particles.
So it will be of uniform. Generally, we use the term uniform. So we have some uniform properties of the particles. Then we call it as a substance. Okay, when a group of particle has a uniform property, then we call it as a substance. Say this substance is generally classified into two. One we call it as elements, and the other one we call it as compounds. So what are elements? Elements are basically one particle, or there is one atom, or basically same atoms. So group of same atoms, we call it as particle, element. Okay, so this we call it as element. Whereas compound,
One or
how-
more.
so two or more substances, we call it as compounds. Okay, so compounds consist of two or more substances, whereas elements will have some atom. We classify them as atomic. Okay, fine. So here in particle, we have individual particle which is described with elements. So which are described with atoms. Say for example, a particle. How many atoms are there in a particle? Okay, and when atoms group together, we have molecule. Right? When two or more atoms, we form molecules. When molecules and atoms are in charged nature, then we call it as ions, right? So atoms are molecules when are charged, when they are charged, plus or minus. When you use that particular charge, we call it as ions. Okay, we mention it as ions. And this particular atom has some subatomic particles. The particles which occur even with the less of atomic status, that we call it as subatomic particles. So what are subatomic particles?
Proton, neutron.
Proton, neutron, and electron. Okay. So these subatomic particles are those which come from elementary particle, that is singular, which forms these group, elementary particles. And these elementary particles are those which you call it as bosons and fermions, right? So these are the new forms of study. So now the elemental physics is more, elementary particle physics is more famous, that you call it as quantum. Okay, so they talk about quantum physics, they talk about all these bosons, fermions, leptons, hadrons, and so on. So all these studies happen here. Previously, 100 and 200 years before, it's all about subatomic particles, right? So likewise, so particles we classify, I mean, we divide them into atoms, atoms into group of atoms will form molecules, and then ions, and subatomic particles. We have protons, neutrons, and electrons, and then we have elementary particles which form each of the proton, neutron, and electrons. Got it? Fine. So in this particular case of elements, coming back to elements, which exist as one or group of atoms, same atoms. So these elements can be classified into metals. Okay, non-metals. So some can be metals, some can be non-metals. Some cannot be classified as metal or non-metal, so you call it as metalloids. Okay, and then you have noble gases. Right? So elements can exist in metal form, non-metal form, metalloids, and noble gases. Okay, so any examples for metal, metalloids, non-metals?
Aluminum, copper.
Aluminum, copper, or popular, what do you call it as metals? Non-metals? Non-metals.
Nitrogen.
Nitrogen, oxygen, carbon. Okay, fine. Metalloids? Silicon, germanium, boron. Okay, so those are metalloids. Noble gases, you know, one group you have noble gases. So you call it argon, krypton, neon, xenon, likewise, right? All these are noble gases. So compounds, you know, popularly organic and inorganic, right? Fine. So these are in general. So according to the section of, or the classification of science, whether it is physics or chemistry or botany or zoology, accordingly you will do it. Okay, so organic matters in biology is different, whereas organic matter in what do you call chemistry is different, right? So the notion is different. So that is how we try to have. So this is a general idea what we have on this matter. Clear? Fine. Similarly, we have a concept of antimatter. So something, say in the entire space, when something exists, an antiparticle will be always there. That is, the opposite will be there always. Okay, so it's a general phenomena what we have. Say when proton is there, we have an electron. So similarly, when a matter is there, we have an antimatter. Okay, what is antimatter? It is an opposite of matter. Okay, how it will be, how it exists.
So is it the God particle?
Okay, so that is here, elementary particles, we call it as God particle, bosons. That's what you call Higgs. Peter Higgs discovered bosons, discovered that particular elementary particle and gave the term boson in honoring Satyendranath Bose, right? So we call them as bosons, Higgs bosons. So we call them as God particles because they are the one which are involved in creating subatomic particles, right? That's the reason we call it as God particles.
Okay, sir.
But what is antimatter kind of? So usually we use it as a term to depict something which is negative, opposite charge. Say for example, what matter is, and same character and property will be there, but it will be in the opposite charge. Okay, positive, and it will be negative. But it will say there will be proton, but exactly opposite, same property will be there, but the charges will be negative. Okay, so in that way we have positron likewise. Got it? So that we call it as antimatter. So same, but it will be in the opposite segment. Okay, it's like a mirror image kind of. Okay, same way we have dark matter. Same matter we have antimatter. Similarly, we have dark matter. What is dark matter? The 80% of universe is covered with dark matter or filled with dark matter. What does it mean? So dark matter is a substance which doesn't emit or reflect light. Okay, that we call it as dark matter. So in the entire universe, what we have is dark matter which neither reflect nor emit any light. So we don't know what it is present. Okay, so that we call it as dark matter. The energy which it possesses, we call it as dark energy. That we'll see later. Okay, when we talk about energy, we'll talk about it. So dark matter, dark energy. So matter is there, antimatter is there, dark matter is there. So that means different forms of existence of something is occupying a space, but we don't know what it is. That is dark matter. Something which occupies a space, but we know its forms, then we call it as matter. Something which occupies a space, but it is similar, but it is something opposite to it. What we thought this property will be in this way, but it will be opposite. That we call it as antimatter. Got it? So every element, everything that is in the atomic particle, especially the particle, we have more of antiparticle, antimatter, so neutrino kind of, right? So all these happens. Got it? So these are some of the basic aspects what we have in the matter. Now, this matter can be at rest or it can move, right? This matter can be at rest or it can move, right?
Yes, sir.
So how this state of rest or state of movement comes in? So that's a fundamental question. So this state of rest or state of motion is set in by a push or a pull. Okay, something has to push or something has to pull you. Then only you will move or you will come to a rest. So you are running, I pull you, you will stop. You are at rest, I push you, you start moving. Got it? So something has to have a push or pull. And this push, we call it as the Big Bang. So in universe, we call it as Big Bang, which there was a blast, an energy blast, and that energy blast had a energy which is pushing everything. So we had the universe expansion and so on, various blah, blah, blah theories we have, right? But whatever it may be, something has to exist or move or whatever has to do in the space. We need to have this particular moment, either push or pull, right? And this push or pull, we call what? What does this push or pull called as technically?
Force.
Force. Good. So this push or pull technically is called as force, right? Okay. So you can push or pull a solid, right? You can push or pull a liquid. You can push or pull a gaseous molecules. So in that particular case, force can exist in either of the any of the forms of matter. Clear? So whether it is antimatter or dark matter or whatever it may be, there may be a force which can be exerted. Clear? Any doubt in this? Done? Okay. Fine. In this, rest is not a problem because it is a movementless, motionless state. Whereas the motion or movement can be of many. When I push you, you start moving, and you can move in many methods, right? So there are different methods in which you can move. So the first one, we call it as linear. What is linear? It may be in a straight plane. Okay. So it can be one-dimensional, two-dimensional, three-dimensional movement. Clear? Clear? So you have a plane. You just move over the plane. This is one dimension, right? In case if you have a plane and you are moving like this, then we have two dimensions. So I have a height component, I have a distance component. How much height I have moved, how much distance I have moved. So it is a two dimension. When there is three dimension, I have a height component, I have a distance component. Also, I have how much, what do you call that, depth component. Okay, that we call it as third dimension. Say, for example, a flight of a bird flying. So direction of the bird will be there. So the bird flies at a height of 10 meters to a distance of 10 kilometers in this particular direction. Okay, in this particular depth. So naturally, I have three-dimensional motion. So it's a linear. So it goes in a particular line. Okay. Sometimes this movement can be circular. So just a rotational movement, circular movement. This movement can also be a wave form. This movement can also be oscillation. What is oscillation? To and fro, front and back. So it moves, comes back again like a pendulum. So oscillation can happen. So there are different types of movements which we can have. Yeah. And similarly, this movement can be continuous, that is uniform or non-uniform. What is uniform or non-uniform? First I may move, I will stop, and then I may move, I will stop, and I will move. So it is not uniform. Okay. It is non-uniform. Uniform means I continuously move in a particular component, right? So it can be uniform, it can be non-uniform, it can be continuous, it need not be continuous, it can be discrete. Understood? So according to the movement, according to this particular conditions, whether it is uniform or non-uniform, continuous or discrete, your force will have a different impact. Clear? Got it? Understood?
Yes, sir.
Fine. So that is the reason why your simple definition of force, that is in simple, you would have learned what force is. So naturally that will have a different meaning when you have a linear 1D, 2D, 3D, circular, wave, oscillation, and so on. Okay. So your formulae will differ. And accordingly, 10th standard, you will have a very simple formula of force. Whereas in 11th standard, two dimension, and in 12th standard, you have three dimension, and in other graduations, you have circular, wave in non-uniform, wave uniform. So there are different methods in which a force can be visualized. Okay, accordingly, your formulae will change, and that makes you actually the physics tougher for people in this particular format. Got it? Okay. Fine. So we had different types of movements, what the force can provide. So, but what are the different types of force we can provide? Okay, that push or pull, who can give? Okay. So the push or pull can be very strong. Okay. So we call it as a strong force. Which is a strong force? We have four fundamental forces. Of nature, which are strong, weak, and we have the weakest of all. Okay, so four forces are there. What can be the strong force? Any idea?
Pull is the strong
Nuclear
force.
force. Yeah. So nuclear force, that is the force exerted by an atom or between atoms. So we call it as a strongest force, right? Then the second, the next one is a weak force, which exists because of radioactivity. Okay, so a decay, a radioactive decay is happening. Then we call it as a weak force. Okay, so strong force, weak force. The third one is electromagnetic force. So it happens between charges, positive and negative charges. So between charges, there are forces. This is the third weak force. Okay. The weakest of all force is gravitational force. The weakest of all forces, gravitational force. So this we call it as the weakest of all forces. This was once asked recently in prelims. So which among the following is the weakest fundamental force? So weakest fundamental force is gravitational force, which happens across any planet or any celestial, between celestial bodies. Okay, between celestial bodies, we may have a gravitational force. So strong force is exhibited by atom. When the atom decays, a weak force is generated. Then electromagnetic force, between the charges, there will be a weak van der Waals forces. Then we have a gravitation force, which is between two masses in the space that we call the celestial body. Clear? So you have four different forces, and there are four different types of motions which can be created by these four different forces independently. A strong nuclear force can have a linear circular wave oscillation. Anything can be created. Same way. Got it? So any combination can happen. Any doubt in this? Hope it is clear. Okay. Now you need to push or pull. So what you need to push or pull? You will push or pull the matter, right? Fine. Say, for example, the matter exists in different forms, right? That is state of matter, solid, liquid, yes. That means all these forces, when act upon a different state of matter, we have different characteristic feature of the force. Clear? So that is the reason when you give a force on a solid, you give a different name. When you give the same force on a liquid, you call it as in a different name. When you put it in the same force in a gas, we put it in different name. So here you may call it as a stress. In water, you may call it as a pressure. In heat, you may call it as the what do you call the thermal movement, right? So in different area, according to the status of matter or state of matter, when a force is applied, the name of the force changes. Why? Because the character of the force changes, or the nature of the force changes, or the consequence of the force changes. So all are different. So we try to have a different thing, but the principle wise, everything will be similar. Okay. When you give a force, if a solid moves, same way a liquid also move, gas also move, but the movement will have different methodology, movement have different consequences. The force required is different. So naturally, we have different names and different observations in these aspects. Fine. So when you push or pull, what you actually push or pull the matter. So what matter is? Matter means something which occupies space. That we call it as mass. Okay. So when a particle or when a substance which is occupying a particular space which has a mass, this mass is constant. Why it is constant? Why mass is constant? Because when a particle occupies a space, that space is always same. Wherever it is put, that space will be occupied. Clear? Say if I'm going to sit in a class, in whatever space I'm going to sit, I will occupy a space. Clear? So it doesn't change. So mass is going to be constant, which is not going to change. But this force can change the implication of mass, correct? Understood? Because what is the property of the mass, whether it is a solid, liquid, or gas? So accordingly, this particular forces can change the character of that particular implication. So when a mass is targeted by a force of gravity, that is gravitational force, there is a change that we call it as weight. Why? The same matter when it is placed on Earth, when it is placed on Moon, it measures differently. Why? Because the force acting on it is different. What force? Gravitation force. Earth has a different form of force, whereas Moon has a different form of force. So ultimately, what happens? The mass which is constant is exhibited differently. Naturally, we call it as weight. So, which is variable here? Mass or weight?
Weight is variable.
Wait.
Weight is variable. So, naturally, your body is measured with the weight. Okay. So, weight in kilogram, not we put it as mass in kilogram. Okay. We call it as weight because your weight may be 60 kgs on Earth, but your weight will be changing on Moon because the gravity is different. Clear? So, that is a fundamental logic. But whether your mass is changing, no. So your mass is going to be the same on Earth or Moon or Jupiter or Saturn, but your weight is going to change. That is the reason why we calculate body mass index to calculate your body, doing away with the gravity impact. Got it? For checking up your health of a body, you conduct body mass index. You don't calculate body weight index. Got it? Understood the difference between mass and weight?
Yes, sir.
Okay.
Yes, sir.
Now, when the mass is there and you push this particular mass, the mass may travel a particular distance, and that we call it as work, right? When a mass is moved to a particular distance, we call it as work. Clear? Any doubt in this? Hope so, no. Now, this particular mass, when I am talking about distance, we talk about, there comes another word called work. When I use this mass in a particular format where area is taken, say for example, in a given area, what is your mass? So mass, when it is applied over an area, this we call it as density. Okay, so density is directly proportional to your mass. So within 1 square meter, how much space is occupied by that particular body? Then I call it as density. More density means more mass per unit area. When I have less density, I have within one particular unit area, I have less mass. Say for example, solid. More mass will be there in a particular given area, whereas gas, one molecule may be there. For solid, it may be thousands of molecules. For liquid, it may be hundreds of molecules. So accordingly, the density will change. When density changes, accordingly, the property of the body also changes. Why? Why when density changes, property of the body also changes?
Area will change.
Because in a given area, when mass is more, when I apply a force, naturally the impact of the force or the implication of the force may be different. Clear? When density is more, the implication will be different. When density is less, the implication is different. Clear? Say for example, you are a dense personality or you have a dense object and I just give a punch on that particular object. The object may not move or object may move very slight distance. When the object, when it is just a balloon, balloon doesn't have any heavy density, right? It is very less dense. So when I just push that particular balloon, the balloon may travel a long distance. So according to the mass occupied, so mass gives you the strength, right? When you have more mass in a particular area, then actually you will be more stronger. So in all areas it applies. Okay, even in politics it applies, right? So in some parties, they may not be densely having their dense voters. So their voters will be sparing like a gaseous molecule. What happens? They may not win any seat, but across the state, they may have some hold. Whereas when I am having a mass vote bank, okay, that is in a particular, I may have 200 constituency, but in 10 constituency, I have a mass vote bank. I may have 10 MLAs. Got it? So that is the importance of mass. So when you have density in a particular area, you have different property. When the density is less, you have different property. Got it? So ultimately, this density is one of the key factors which is directly proportional to mass. Right? Fine. So now this particular mass is moving a distance. So what is a distance? Distance is shortest length. Okay, what is distance? Shortest length between 2 points. Why I use shortest length between points? Say there is Delhi. So there is Agra. Okay, so it may be say 100 kilometers. You say, what is the distance? You say 100 kilometers. I may say, no, it is not 100 kilometers. It is going to be say 500 kilometers. How do you say? Say I travel to Jaipur. Via Jaipur, I may go to Mathura and then I reach Agra. Okay, I will travel 500 kilometers to reach Agra. Right, but it is not the correct distance. Why? Distance means it is going to be the shortest length. So what is the shortest length between 2 points? That we call this distance. Got it? Fine. So body moves from one point A to a point B, then I call it as distance. When this distance is covered by the body, I call some work is done. Okay, some work is done. Clear? Okay. Now you ask me, I have done a work. So I have moved a body from point A to, I have moved a body for a distance of 10 kilometers or say 1 kilometer. So I have done some work. Okay. So you are asking in which direction you went, because I say I moved a body 1 kilometer. Okay, you don't know which direction. So when I start providing direction, I call it as displacement. So what is the difference between distance and displacement? It is only direction. When I say I moved a body to a 1 kilometer distance between point A and B, or from point A to B, then I call it as displacement. That 1 kilometer, I call it as displacement. When I say it is distance, it is just a number. I moved 1 kilometer. Okay, fine. In what time I have moved it? When I take time, how many kilometer I moved per 1 hour. Okay, then I call it as speed. So this I call it as speed. So how many distance I travel per kilometer, I call it as speed. If I use displacement, I traveled 1 kilometer per hour from A to B, then I call it as velocity. So what is the difference between velocity and speed? It's same like distance and displacement. Distance is just a number. Displacement is number with direction. Speed is just a number, whereas speed with direction is velocity. When I say he traveled at a velocity of 100 kilometers per hour, that means I should say from this point to that point. Then only it will be considered as velocity. Otherwise, I will consider it as speed only. Understood? Understood how distance, displacement, speed, and velocity comes in?
Yes.
Any doubt in this? Okay. Now, say for example, that the velocity may not be constant, say when you start a bike, the starting point, it may be 0 kilometer per hour. Then you may raise to 50 kilometer per hour. Then you may raise to 80 kilometer per hour. All of a sudden, there may be someone crossing in between. So you come to 30 kilometers per hour. Then you raise it to 120 kilometers per hour. So there is some path in which it moves. So 0, 50, 80, 30, so 120 and so on. So in that particular case, the velocity is not constant. Okay. So in given time, so how this particular velocity changes, we call it as acceleration. So what is acceleration? In a given time, how much velocity is changing, the rate of change of velocity in a given time. That we call it as acceleration. So distance doesn't have that problem, whereas for speed or velocity, we have this problem. So what we have this particular property of what we call it as acceleration. Okay, understood? So these are some of the important aspects. When a property changes or when things are getting to the different mode, so we have different aspects which is coming in. So we have speed, we have velocity, we have acceleration. Got it? Okay. So now you know what is mass, what is speed, what is distance, what is acceleration, and fine. Now I from a top building, okay, building top, which is almost a 10-story building. Okay, I drop 1 kg of iron, okay, and I drop 1 kg of cotton, which will reach down first.
Iron, sir.
Iron. Okay. Why?
So both will reach at the same time.
Both will reach at
Well-
same time. Okay.
Iron will reach first.
Hmm.
Due to
Why
its
iron should reach first?
Weight and
Due to its
density.
Weight is same, 1 kg, 1 kg.
density, sir.
Density and
Density
force.
is different, right? So naturally, the weight is altered. So accordingly, you have that particular thing. Why you say in this all, what notion you always take it? What
Gravitational
factor
force.
you take into consideration? Which I haven't mentioned, but you take it into consideration. What you take it?
Force of attraction, sir.
That is gravity, right?
Yes, sir.
So you take into consideration gravity, because I say from the top of a 10-story building, I put these two down. So automatically you take into consideration gravity. Okay. So gravity, due to gravity, we have some acceleration. So iron and cotton may have different according to the shape and size. Clear? Because
Yes, sir.
there is a factor called air resistance. Clear? There is a factor called air resistance. So when iron is, say, for example, 1 feet length and cotton bale is around 1 feet length. So the air may be resisting this. Clear? The air resisting the iron bar, since iron bar is more denser, the resistance offered by the air may not be a factor. Whereas for cotton, since the density of cotton is different, so automatically this density of the cotton may be reacting to that particular air resistance, so the speed may be lowered. Clear? Okay. So the density is very important. Say, for example, you throw a pillow, cotton pillow on a particular person. Will it hurt?
No, sir.
Slightly, sir.
So it may not. It may be slightly, right? It may not. But when you compress the cotton and make it into a small duster kind of, and you just throw it, what will happen?
It will hurt.
It will hurt. So density of the object definitely changes the property of that particular object. That is, one may not hurt, whereas the other may hurt. Why? Because of the dense molecules, what it happens. So similarly, the air resistance will also play a major role. When I make air resistance as 0, what will happen now? When I call it as air resistance 0, I don't make gravity as 0. Okay.
Still iron reaches first, sir.
Huh?
Still iron reaches first.
Really?
No, sir. Both.
No, sir. Both are rich.
Both reaches.
Both will reach at the same time because both are 1 kg, right? Both mass are same. Air resistance is 0. That means you are putting it in vacuum. Okay. When air resistance is 0 means air is 0. That is, in vacuum, when you drop, both will come at the same time because both have gravity of 9.8 meter per second. Okay, no problem. Okay. When gravity is 0, what will happen?
It won't fall down.
It won't, both will not fall down. It will be just floating over, right? Understood?
Yes, sir.
When gravity is 0, even when I drop it, it will be there. Clear? Because there is nothing to attract it down. Clear? When air resistance is 0, it will fall, but fall equally when there is equal weight. Understood? Remember, when air resistance is 0, we call it as free fall. Okay, what is free fall? There is no resistance of air. That we call it as free fall. Okay, gravity will exist. When gravity is 0, we call it as weightlessness. Why I call it as weightlessness? I feel that I don't have any weight. Got it? In moon, what you feel? In moon, In earth, you are upright, whereas in moon, you will float. Correct? Understood. That's the
Yes, sir.
reason why you have jump and walk, right? So you'll have that weightlessness. Why that weightlessness? Because gravity is minimal there. It is not zero, it is minimal. When it is zero, you will start floating. Clear? Microgravity. When you create a microgravity, you will be just floating because there is nothing to pull you down and keep you intact. Okay. So you are not actually, your weight is not zero, but you feel that you are zero. Understood? That is the reason we call it as weightlessness. So when they give these terms in prelims, already they have asked it in prelims. When they say free fall, that means air resistance is zero. When they say air resistance is zero, it means free fall. Similarly, when they say weightlessness, gravity is not there. Okay. When there is no gravity, you will not feel your weight. You will not feel your weight. So when gravity is zero, your weight will not be seen. When your gravity is more, you will feel more weight because the more attraction will be there. Got it? Simple.
Yes, sir.
Understood the basics of these weight, mass, and all these aspects. So because they play with the words, say what they will do. When air resistance, when there is a free fall of a body, which one of the following is correct? So air resistance is zero, gravity is zero, both gravity and air resistance is zero. It is either of the one is there. So kind of words will be juggled out. But this is the basic logic how it happens. Fine. Okay. Now, when these force existed in nature, okay, so through the time period, the force existed, but we started identifying force. So, who identified the force? It was Isaac Newton. So, popularly, you know that Newton was the one who identified the force, and he started having this large part of his study on force. So, the popular saying will be there when he was in his university ground. So he was under an apple tree, apple fallen on him. So he thought why the apple has to fall. So it is Newton's lucky thing that he was there in Europe. So he had an apple to fall. So if he was in India, there may be a jackfruit tree or a coconut tree. Naturally, that would have led to the death of Newton. Anyway, so he was lucky enough to sit under the apple tree and he was thinking about how apple fell and why apple fell, right? So he started throwing away the apple. The apple fell at a distance. So he had many questions. So apple fell on him vertically down. But when the apple was thrown, it was thrown somewhere. When it was thrown, it was somewhere away, right? So it goes away. So it didn't fall at the same place. So there are many questions what Newton had, and he tried to check this particular property of falling. So he actually studied property of falling, and he understood how the fall happens, and that is how he took up the idea. He went to a building, he dropped something, so it dropped far away. So that is how he understood how things drop on earth. Okay. Say, for example, from here you just throw, it will fall here. From a height, it will fall here. From another more altitude, it will fall here. From even more altitude, it may fall here. And from even more altitude, it may fall, but it will continue to fall. Okay, it may fall, but it will continue to fall. So when he understood that it may continue to fall, then he understood that there may be a concept of gravity. That is, there is something which is attracting towards a particular object, and that will keep on attracting, but it will keep on falling. Okay, and that is how he said, moon is rotating, or a natural satellite is rotating around the Earth, right? So before this, all these things led to the idea of force, what he called it as push or pull. and he gave the laws of motion. He gave the laws of motion and he understood what mass is. And before him, there were people who talked about mass. There was law of conservation of mass. What is conservation of mass? The total mass in the given system is constant. That say always remember conservation theory will always say the entire system something is constant. Conservation of energy means energy is constant. Mass means mass is constant. Okay. So that is what he called. So it is going to be constant. How it is? Say for example, you take a forest, an ecosystem. So there is an elephant which is 7 tons. Okay. So there is a hippo which is 5 tons. There may be a tree which is 100 kgs. Likewise, when an elephant dies, what happens? The conservation of mass says that this 7 tons, that is 7,000 kgs, will be dissipated in the mass itself. How? The elephant, say for example, the skeleton may be 3 tons, so it will be remaining. Okay. Remaining 4 tons, it may be the other organs, the tissue, the other aspects, all things will be converted into the mass of another body. Say for example, a lion eats a pound of meat. So that pound of meat will be converted into a body mass of the particular lion by converting itself into a food or energy, whatever it is. So this conversion, at the end of the day, the 7-ton elephant, the mass is always present, but in different form. And that is the reason why they say, whether it is energy or mass, so it is nothing to be created, nothing to be, when they, especially in energy, they say it is neither energy is created nor it is destroyed, but it transforms. So say, same way, mass, it transforms the mass from one to the other. So plant mass is converted into an animal mass. The animal mass is again converted into a plant mass by decaying in other substances. So to do this, for this conservation of mass, there is a huge ecosystem which operates. That is what biology says. How this particular huge chain of food web, food network, and so on, what all the things you have, all these things will be there. Got it? So that is how it is going to happen. Same way, when he talked about, when there is an understanding about mass, they started understanding about motion. Okay, so different types of movement, how it can be. But here he always talked about linear. Okay, so he talked about linear, and one time he talked about circular. Okay, so anyway, so here there are 3 laws of Newton. So Newton's 3 states laws, which talks about laws of motion. So what is the first law? What does first law states? Huh?
An object remains in the state of rest or
Hmm.
continuous motion until and unless an external force is.
So he says that the body will be in a state of rest or uniform motion unless or otherwise an external force acts upon it. And he says that the body will act according to the property of that particular force. Natural, right? Say you can apply it in the Newton's law is directly applicable in your life. You will sit and study properly. You will be constantly studying. There will be an external force, that is your friend or a colleague. So they will come. How far their strong influence is going to be. So what you are going to read now. So for past 3 years, 3 hours you are reading. So we'll have a relaxation. So you may resist, you may budge. So how the resistance comes, if they just asking, say whether you are going to come. So you may say no. Whether they are pulling you and going out to say what you are studying, come on. Then you will budge, right? So according to the force, what they actually apply, so your movement will change, right? So same way, any body which rolls, whether it is rolling or whether it is going to be at state of rest, according to the force which is going to act, so naturally it is going to happen. So here what he says, mass is going to be there. And he talks about acceleration, that is motion. So ultimately there is something called as mass into acceleration. Sometimes you may resist, right? Say when your friend asks you, you come, you say no, right? So you resist. What is this resistance comes in? So sometimes I push, but the body doesn't move. So Newton says that there is some resistance, and that resistance is called as inertia. Okay. So the first law talks about law of inertia. So what Newton say, if you want to move somebody, there will be some resistance. If you want to move really, you need to have something which is more than that particular resistance, right? Say, I want to make you study, you may resist. But how I should make you study, I need to use some more force than the resistance so that the resistance will break and then it has to move, right? So this is where he say force is proportional to the mass and acceleration. What is the acceleration you need? Or whether you need to stop down the acceleration, whether you need to give the acceleration, and what is the mass of that particular body. According to the proportion, I need to exert that particular force. Otherwise, I will not get the required change. Got it? And natural, you can see in society, every social change will have an inertia, and the social reformers will be so blatant against these particular inertia, and they would have came down heavily upon them, directly attacking that particular resistance, and they will make the change. Got it? Why you need violence? Why you have social violence? Why you have social pressure? So you can see the social reformers will be very, very aggressive. Why? Because the society will have a basic inertia. Newton says that inertia has to overcome for the force to act. So naturally, you will be aggressive. Got it? So in that particular way, what happens? This inertia has three different types of inertia. The inertia at rest, the inertia at motion, the inertia of direction. Right? The inertia of direction. Say you will be at rest. So you get into a bus. The bus is at rest. You are also at rest. You are seated. Now all of a sudden the bus starts. What happens? You will push yourself back. Okay. Why? You want to stay at rest, but the bus is starting to move. So naturally, you resist to move. Okay. You resist movement. Right? You resist movement. Same way, the bus starts moving. You move back, and then you adjust, and then you travel with the bus. Right? So the bus is in state of motion. All of a sudden, the bus stops. Okay. What happens? You resist stopping. What happens? You continue to move. That's the reason why you fall in front. Got it? So resistance to stop. Whereas direction. So resist a particular direction and continue. You try to continue in a particular direction. So you resist the change in direction. Okay, here you try to resist change in direction. How? When you start traveling, the bus turn left, you turn right. Okay, so all of a sudden the body will push to right. When the bus turn left, the body will push to right. Why? The body is not pushing to right. The body actually wants to put it itself in the straight motion. Say, for example, the bus is in this direction. All of a sudden the bus turns, but actually the body wants to continue here. So the body tries to keep it in motion. Okay, so this change in direction. So if it is here, the body tries to put it in this particular direction. So you are resisting the change in direction. You are resisting this change in stopping. You are resisting the change in movement. Accordingly, you have direction, motion, and rest. Got it? Inertia at rest, inertia of motion, inertia of direction. Clear? So all these resistance to change comes out of first law. Clear? Fine. Now, then comes second law. The second law is very important. Why? Because here he talks about a concept called momentum. I started pushing you and the body moves. Okay. But it has to continue to move, right? I have motivated you to study, but I have to keep you in that particular motivation itself. So for that, you need momentum, right? You have inertia. I have broken that inertia. So you start moving in the direction where I want to. But I need to keep you in the same pace. Okay. So that we call it as momentum. So what Newton says, momentum. And this momentum is a rate of change of force. Say, for example, I want to have a pace. You are coming with that pace. I am not going to force you anything, right? Say, for example, slowly you come down with your studies. So I need to push you again. So at what time I need to have what type of force or what amount of force, that I call it as momentum. Okay, momentum is rate of change of force in a given time period. Got it? So this again, conservation of momentum, we have a separate topic of conservation theory, conservation of momentum. So given momentum is constant, right? Okay. So this momentum at times, all of a sudden, in a say you just slow down, I just push you again. Okay, within a small fraction of second, I give a very high force. What happens to you? You'll feel a very high impact, right? So all of a sudden, you didn't expect anything. A push is given to you. What will happen? You will suddenly fall. Okay, that he calls as impulse. So what is impulse? Impulse is nothing but the force in a given time. So how much force I'm going to give in a particular time? A very high force within a small fraction of second. I call it as impulse. Okay, so kilogram per meter per second. Okay, within a second, square of a second, within a given unit of meter, so some kgs are falling. Okay, that I call it as impulse, and that's the reason within a second, within a very small area, meter only, right? It is not feet or something, it is just a meter. You have 1 kg is going to fall. So think how much weight is going to have an impact. So this we call it as impulse. So we can find that impulse when you receive a ball. Okay, in a cricket, you are just having a shot, the ball reaches the fielder. The fielder tries to catch the ball, but not stop the ball. Okay, they don't stop it, they just catch it. So when they catch, they drag their hand. Why? To increase the time and to increase the area of impact or the time of impact. Thereby, they reduce the influence of impulse. Otherwise, what happened? When I just stop it, so within a second, 400 kilometer speed, the ball hits that particular hand. Naturally, the force which is exerted is very high. But when I just drag it, the time span is increasing. So naturally, the impact will also be less. So here he talks about conservation of momentum and he talks about impulse, right? Impulse is one of the important aspect what we have. Clear? So ultimately, we can see that law of conservation of momentum is one of the important aspect because you need to constantly have that particular force which has to be there, but you cannot have an impulse because impulse can destroy that particular body because in a given second, in a given meter area, there will be a huge force which is acting. Yeah, fine. Now comes the most important, the third law, which is a very, very important law for your life. So this particular third law is nothing but it talks about torque, rotational force. Okay, torque is nothing but rotational force. But it says every action has an equal and opposite reaction. He says equal and opposite reaction. Okay, every action, whether it is good or bad. So every action will have an equal and opposite reaction. And this particular force which is given will be countered by another force. Okay. So when he says this, when a plane is there, you have a point here, midpoint. And when there is a force given like this, he says there is a force which can happen here. So it can happen here, it can happen here, anywhere, but it will be opposite and equal. Okay, it will be equal. He says that if this particular distance is equal, okay, so remember, when I give a force here, the opposite force can happen here, anywhere. But when the same force appears here, where the distance between these two are equal, then this can move or rotate. That I call it as torque. So the minimum force at a distance from a given point required to rotate this body or the plane, I call it as torque. Understood? The minimum force in a given point of time, which is perpendicular. It should be perpendicular to each other and it should be at an equal distance between the point, then it can rotate that particular body or a plane. We call it as torque, the rotational force. Got it? Any doubt in this? Fine. So all these aspects are the three forces what he handled. So there are different other forces. Say we call it as negative force. So what is a negative force? The force which is opposite to a body. Say for example, gravity can be a negative force when you fly towards top. So when you are flying away from here, gravity can be negative. Okay, because it is opposite to you. So when body movement is like this and this particular force is acting opposite, then we call it as negative. So gravity can be positive also. When you come back, so gravity may be positive, right? So gravity can be negative, gravity can be positive. Purely negative is friction. Friction force is always negative. Why? Because friction will always act against you. Okay. But in order to be stable, you need to be stable. Then you need friction. In your life, if you want to have stability, you need someone to oppose you. Okay. So if you are a ruler, if you are an officer, if you are a general person, if you have a thought, so if you have a stable thought, if you want your thought process to be stable, there should be a person who has to have an opposite thought in that particular direction. Why? Because then only they will question your thought. You will just sharpen your ideas. That's all. So friction force is the one which really there should be to have a stability in a particular body, because then only the body can move, then only the body can move stably and so on. At times you need to have this particular friction reduced. Why? To have a smooth flow of body. Okay, in a plane, when a body should move, there cannot be always a friction. There can be even a smooth flow of body. So you need to have reduction in friction. So we have many methods to reduce friction. One of the best method we found was ball bearing concept. Okay, so you have bearings. So you may have 3 or 4 bearings. The point of contact of the bearing is very minimal, because only these 2 points in a bearing will touch the 2 body, and it will be filled with grease. So smooth, what do you call, the slippery surface is created. So automatically we have a reduced friction. The most the most easiest thing is this, but the most efficient thing what you can have is levitation. That is, you have 2 surfaces, but you have gap between surface because of magnet. So you create a friction, but that particular friction will be very less. Okay, that is magnetic levitation. So that is the advanced form of how we can have a very less friction between 2 surfaces. So negative forces can be there. There is another concept of force called resultant force. So what is resultant force? Say for example, you have body. Okay, I apply 5 Newton of force here, 6 Newton of force here, 3 Newton of force here. Okay, and 10 Newton of force here. In which direction the body will move? In which direction body will move?
Southwest.
Downwards,
Like that.
Downwards.
Towards-
Why?
because there's more force coming from the top and compared to what it's at the
Okay.
bottom.
So here 5 is there. Okay. So here 3 is there. So 3 and 5 is almost because one is pushing, the other one is pulling. So totally it is 8. Okay, it is in the same direction it will go. So here it is 8, here it is 6. So definitely it will not move top, because this will be cancelled with these 2. So remaining 10 is there, here 2 is there. So ultimately it has to move in this direction with 8 Newton power. Got it? So this 8 Newton is a resultant force of this 4 different forces. Got it?
Yes, sir.
Okay. Resultant is something, the result of the entire forces. Don't confuse with torque. This is not a resultant force. This is a reactionary force. Okay. A reactionary force is not a resultant force. Resultant force is the net force which is acting on a body. The torque is the reactionary force for the action. When this action is removed, when this force dies, this automatically will die. Got it? Fine. So this is what basically what we call it as force. Any doubt up to this?
Sir, will that
Ah.
object not move in like a southeast direction?
In case of that, say, for example, I should have drawn in this way so that it should be very clear. So in this, it will be down. In case if it is slanting, so if this is slanting, naturally the body will move, slide here, slide in this direction. That's it. Okay. So what will be the direction of the resultant force? That will be the direction of that. Simple.
Okay, sir.
Any other question? Okay. Fine. Now, you had the rotation force. What is this rotation force? We call it as torque. Okay. Fine. I have given a force to do a work. Okay. I have a force to do a work because when I give a force, there will be a movement. Movement means work done, right? Okay. When, if I want to calculate in what time you will do this work or within a what time you will do this work. Say, for example, for doing this particular work, how much time you will take? Okay. Say you say, I will take 1 hour. Some says I will take only half an hour. Okay. And one say I will have 1.5 hours. Got it? So the person who does this particular job or a work in half an hour, what you will term this particular person as?
Power.
So a powerful person, right? Because he does the work very fast. So he is a powerful person because he is doing the work faster. That means the rate of doing work is power, correct? So what is power? Within this particular time, how much work I can finish? Okay, fine. Say, for example, one person does a job in half an hour, but take a rest 1 hour, and then he will do half an hour job. Got it? So he will work for half an hour, and he will take a rest for 1 hour, and he will do another thing in half an hour. Okay, next job will be completed in half an hour. One person will take 1 hour to do the job, but he will take only say half an hour rest, and he will do the job, next job in 1 hour. Okay. So what is the total time taken? What is the total time taken to finish a job?
It's 2 hours in the first case, sir, I think.
Okay, 2 hours. Okay. Here,
2.5.
2.5 hours. Okay, fine. So first one, 2 hours. The second one is 2.5 hours. Fine. So who is having the capacity to do work continuously? Between this 1 and 2.
I think 2, sir.
2.
Two, sir.
Why?
He's
Because
taken
he
two.
didn't
He
have an
took
open-
less time for break.
Because he has very less time for break and he could work continuously, right? So this capacity to do work, what you call it as stamina, is nothing but energy. So what is energy? How much energy you have, you possess, that I call as energy, right? So work, power, energy. Work, how much force I require to do this particular or move this particular body, that is work. Okay, I put it as a push or pull which I require, right? It is joules, work done. So how much time this particular work is done, or within how much time I can do it, that I call it as power. So power, previously we used horsepower. 1 horse can do in this particular method. That particular person, how much power they can use. Okay, horsepower was there. Now we have watts. Okay, usually we use with watts. Now we have energy. What is energy? This power, how much continuously, how many time it can burn, or how much time this particular power is present with you. That I call it as energy. So that is kilowatt hour. What I call it as kilowatt hour. So this is a general unit what we have, kilowatt hour, for depicting energy. That is the difference of differentiating the power with time. I have power till what time? Okay, that is energy, right? I can do the work till what time? That is power. Got it? Understood?
Yes, sir. Sir, but the joules is used as a unit for what, sir?
So here work, we can use joules. Energy also you can use joules. If you want to use watt, power can also be used as watt. Energy means kilowatt hour. Kilowatt in hour. Because it is, again time will come, right?
Yeah, yes,
So
sir.
we have watts in hour, usually in kilowatt, because energy has a very large value. So we usually denote it by kilowatt. 1 kilowatt hour is 1 unit. That is what your current capacity is. Clear? Energy is joules per kilowatt hour. That's the idea. What? Clear? I mean, sorry, joules or kilowatt hour. What you have? Fine. Done. Power will be joules per second. In 1 second, how much power, how much joules you spend, that is power. Clear?
Yes, sir.
That's right. Understood. So here we have energy. So again, law of conservation of energy comes. So conservation, we have in force, we have mass, we have momentum, we have energy. So here the energy conservation is very important because we clearly understand the energy is neither be created nor be destroyed, but it can be transferred from one form to another form. And here you need to have clarity about what is power versus what is torque. Okay, torque is the force or power. Power is something which I consider as speed. Okay, torque is something which I have for rotation, rotating a particular thing. Okay, a lorry needs more torque or more power.
More torque.
More torque, right? More torque. Correct. Just. So any doubt up to this? Fine. Okay. Done. Yeah. For rotation, it needs torque. That is how the lorry needs more torque, whereas a car needs more power. Okay. Initially, the torque will be there. Any body, initially torque will be provided to move. Then only the wheels will rotate. But according to the weight of the body, that is a duty of the body. Say lorry, it needs to carry more weight. So naturally, the torque will be more, the speed will be less. Whereas for car, the torque will be immediately converted into a power because it has to move in speed. Okay. Thank you. So when a car has more torque, when you buy a car and the torque is more, Newton meter, 230 Newton meter, that means when you at a full capacity, that particular car can move at a good speed. Okay. So otherwise it will be slow in moving at a full capacity. Okay. So the initial stage. So that's how the torque capacity will be. Usually when you see SUVs, you can see that high torque will be there because 7, 8 people will be there. So 8 into average 60. So that will be around 240 kg weight, sorry, 480 kg weight. And vehicle itself will be 1.5 tons. So all put together, it has to move. So it has to move quickly. So that means initially torque will be very high. Whereas a small car, so only 4 people or 2 people will be there. So less torque is required, but more speed can be there. Okay, so that is how they do calculation. So now in this, when we have this particular thing, I will just put an indication. Next class we will do because just first class I don't want to put all things in one go. So here in solid, liquid, and gas, how it is, we will see. In solids, when we have force, so we call it as stress, strain. Okay, so we have elasticity. Okay, so what is elasticity? We try to signify. So when I give force to a particular solid, whether it will come back to its own position or not. Okay, plasticity, elasticity. Okay, so whether it is going to deform or whether it will permanent deformity or whether it is not going to have permanent deformity. Okay, so likewise. So all these we have, and then to calculate this, you have modulus kind of, say all these are not required. I'm not just explaining all these. I'm just indicating how force is replicated in a solid. Got it? So you have elasticity, you have solids in this particular aspect. Same way, when you have liquid, so what are the things in liquid or fluid happens? So I'll put it as fluid itself. Why? Because air and gas, water and gas almost the same kind of. So fluids, that is liquid and gas, right? So in fluids, what are all the things you have? We call it as pressure, right? Force per unit area, we call it as pressure. Up, we put it in different terms called upthrust or buoyancy. Buoyant force, right? Upthrust or buoyant force. So you may see sinking or float accordingly. Okay, upthrust and buoyant force. Accordingly, you have sinking and floating. Okay, so similarly, you have distribution of pressure. So how force is distributed, same way pressure is also distributed. So you'll be talking about the thing. Then center of gravity, you'll be talking about. All these are based on force, right? In case in gas, it will be all about heat, the force, how the force is put in heat, and how heat transfer is going to happen. And in that heat transfer, we'll be talking about conduction, convection, radiation. Correct? So this is how it will be, and how the thermal conduction is going to happen. So accordingly, you are going to have this particular change in this aspect. Yeah. And according to the force, the fluid or gas will have the flow, nature of flow. That's the reason why you have different types of flows, what you have, different types of properties you have displayed. So many, say in prelims, many questions have been related to fluids only. Okay, pressure, they may ask you Pascal's law, Archimedes principle, or it might be Bernoulli's principle, kind of. Apart from that, mostly surface tension, capillarity. So all these aspects are force and fluid. So force fluid combination is more questions which you can find than force with solid or force with gas. Okay. So this is a point of when you find many questions. When you see the previous year question, many questions will be happening in this particular area. So try to concentrate these area. What is pressure? What is surface tension? Why surface tension is important? What is capillarity? So moving of liquid in a small holes, how it happens. So all these you can have a clarity upon. Okay, you can just have a thought process. And similarly, when you have surface tension,
One in solids, sir. Fifth one in solids.
modulus and all not required. See, solids almost it is not required. They are not much of strain, stress and all. No questions you would have seen. But here, surface tension and all, the different types of surface tension, it can be cohesive, cohesion, adhesion, all these have been asked. Okay, so how cohesion happens, adhesion happens, how you had the concept of what do you call the capillarity happens. So all these things have been taken care of in this aspect. Okay, and similarly, when you have the other aspect, heat. Okay, heat mostly they concentrate on conduction, convection, radiation, those aspects, and they haven't. That is basically transfer of heat. Okay, and then black body, black hole, black body. What is the character of black body? What is the specific heat capacity? So what is carrying capacity of the heat? Likewise, latent heat, specific heat. Okay, so those areas. So these are the basic areas what they have largely concentrated upon. Okay, so you can just have their definitions in this particular aspect, and the time permits we'll just see one by one. Okay, in various other aspects, but the most important apart from these force and other aspects, the most important aspect is light and sound, which is the fundamental area where we have more number of questions. Anyway, we will see light and sound separately when we talk about spectrum in space and so on. So for that reason, I didn't put it out here. So in this, what we have is more importantly, light and sound. They will ask you all about the spectrum properties. All properties of light have been asked, whether it is you take any property, particle property or wave property, and similarly for sound. So all such properties have been asked. Okay, so they have exploited almost all aspects of light as well as sound. And similarly, visible spectrum. So in visible spectrum, the IR to UV. So all aspects, that is energy, wavelength, all these aspects. And similarly in sound, the basics of acoustics. So they have asked that what is echo, what is beats, what is vibration, what is harmonics, overtones, all these have been asked. Okay, so light and sound. So we will see it separately also in the next session. When we talk about space and other aspects, we will cover it. But this is something significant, important area. You can just revise the previous year question itself. That will give you a good light on how they are asked. Okay, so what are the properties and how they ask all that. Okay, so these are some of the basics which you need to remember. Apart from that, these light and sound, similarly, you have a relationship with eclipses, solar, okay, solar system. So eclipse, your different types of shadows, okay, all these have been asked for. So these are the overall basics what you need. Okay, so beyond this, I haven't seen any questions regarding these. They revolve, basic means they revolve around these areas. So those people who are appearing in this year, so you can, if you want to concentrate on basics, you can concentrate only in these areas, and you need not worry about the other basics, right? So this is and that to the 10th, 11th basic level is required. And similarly, light and sound, if you want, say non-science student, you don't want to do anything with science, you just want to have the current updated one. You want, you can have light and sound as a base. You just study and go 1 or 2 questions. Definitely, you can have a click over, because it is just a common sense approach. It will be okay. It will not be, no facts is going to be asked. Remember, they won't go with facts. Okay, it is only the concept, and that to a common sense approach they will concentrate on. They don't trick you with the facts and all. Okay, so it is just a common sense fact they are going to ask. So in that way, you can easily get 1 or 2 questions right when you basically prepare these light and sound part. Yeah.
So what would be the weightage of marks in prelims and mains?
So
for science?
weightage in the sense hardly 10 max. Okay, I'm talking about max. Okay. So all put with technology and other stuff. Okay, so maximum 10 questions you can expect. So say it is just an average. So sometimes it may cross 10 or less than 10, it can happen. But generally you can expect around 10 on an average. Okay, so it depends upon what they ask. Say sometimes there may not be any basic questions, light, sound, and so on. It will be more of technologies. It can be. Okay, sometimes less of technologies, more of basics they can ask. So sometimes both have been asked equally. So for prelims, you can expect any side, okay? Because before 2013, predominantly it will be more of what do you call science, whereas technology will be in mains. Whereas now technologies are also there in prelims. They are asking basics of microwave also. Okay, so microwave means what in that particular way, what you can find out in this basic microwave operation. Okay, that they put it in everyday life. So everyday life is something a very tricky thing because it encompasses anything. So it starts from your near field charging to it goes up to your satellite communication because everything you use in everyday life, right? So when you charge a mobile with the using of near field technology, yes, of course they can. Okay, Bluetooth, Wi-Fi, Bluetooth, what do you call it as anything called as WiMAX technologies. So all other new technologies, what you have, all these comes under these everyday life. Okay, so this is how things are. Right? So that's a vast kind of thing that everyday thing is. So microwaves, but anything which you find it in your own speed. Okay, so notes means what you are asking about. How to make notes in this or class notes. Class notes you will just you can have these notes while we have it in the class. So because it's more of interaction only. But what you should do is we have given the topic, right? So you have some sheets of paper or in case if you are having a soft copy note. So you have one page for every topic, say space or nuclear. Don't write facts and all. Try to have technology alone. So what technology have? Say, for example, in space technology, sometimes re-entry technology they have talked about. So what is re-entry technology? So that alone you take a note. Okay. Similarly, in defense, so India DO some technologies introduced. So canisterization technology or miniaturization technology. What does it mean? Okay. So that alone you take notes and add on, keep on add on for through the preparation. Yeah, that will help you. So nanotechnology and all, nanotechnology, biotechnology and the application. You will get more examples, live examples. Say you will all of a sudden you will get a news. In nanotechnology, using nanotechnology, an artificial skin has been developed and it has been used successfully. So that is one example, a live example which you can quote. So add on to that nanotechnology part. This is how you need to develop the notes. Don't depend upon any specific book, what you have. It won't work because it will become static, right? So concentrate more on application and examples. So that will help you present a good answer in mains also. Yeah.
So what would be the scope of the defense technology in the sense and new missiles and new things like
Yeah,
that?
that we'll discuss. I will tell you when we talk about space. I think tomorrow we'll go with space. So what are all the aspect of space? We will split that space into various forms, 4 or 5 forms, right? So what is space system? What is space instruments? What they are institutions? So likewise we will split. So same way you can split for defense and nuclear also. So when we split that, you can easily identify what are all the areas we need to consider, which is static, which is not. Okay, so static part you can have some notes from new magazines or whatever it is. So the current affairs part, how to add it, that you can use in this particular method. Yeah. So that we'll discuss tomorrow also when we get into space bar.
Yes, sir.
So tomorrow when you come, you try to have some input on Kepler's law. Okay. What is Kepler's law? What is Newton's law on gravitation? Okay, likewise some basics you try to have a note on the space and come. Okay, so what is space? What is dark matter? So some basics. If you have some notes, you try to have it have a reading and come. Okay. So any other questions? So how the pace is okay for you? Can you travel with me? So should I slow down? Whether you could travel with my pace or whether I'm faster or slower, because some may be new to me. Is it okay?
Yes, sir.
Yes, sir.
Fine. So in case of
Yes,
any
sir.
issues, you can always indicate me so that I can slow down in case if the concept is not clear to you. Always you try to have questions or in between. In case if you couldn't understand, definitely you try to pose a question then and there. Okay, so that it will be easy for others also to get it clarified. Okay, thank you very much.